Okay. I'm Jorge, and I'll talk to you about MinVayu and our project to do water pumping systems. Actually, that's the latest turbine that we installed. It's, I guess, a 2.5 kilowatts on a 27-meter tower. It was installed a couple months back. What is the need? Basically, in India, we have around 26 million diesel pumps, 3 to 5 HP in size. So the idea is how to tackle that. I'm not going to tackle 26 million, but it would be nice to produce some and exchange them with wind electric water pumpers. There's a government program. Actually, in India, there's a lot of programs. There's a lot of targets. In this sense, we're talking about a target of replacing 200,000 water pumpers, diesel water pumpers in the next 5 years. There's a government target, but they don't know what to do or how to do it, basically. So hopefully we can give them one solution out of many. Probably most of them will be solar. One of the ideas that are out there is the fact that you replace a diesel with a solar water pumper. A problem in India is overpumping. So people are depleting the water table. So part of the idea is to put drip irrigation or install a drip irrigation and a water pumper, and solar or wind electric or whatever goes in there. But everything takes a long time, so I think 5 years will be too little. Maybe it'll take 10 years to do that. Anyway, the goal is to develop and start installing systems that would be basically a wind turbine, a three-phase Piggott turbine, and connected directly to a three-phase pump. It could be a submersible pump or a surface pump. There's been a lot of experiences around the world. I think most of the experiences that I've found have been in Texas, for example. Tests done with Berge wind turbines, tests done with Whisper wind turbines in the 90s, like 20 years ago, 10 years ago. So there's some experience out there, but no manufacturer has really been able to kind of break the mold and really develop a market for this. The only place I've seen is in South Africa in 1997 or so. They were installing some of these water pumpers, and there was a dealer that installed a couple hundred of them. Then the company was sold to Southwest Wind Power. I used to work at Southwest Wind Power, and I was in charge of trying to develop this product. And ever since then, I've been with this bug. We worked with Grundfos, and they developed a water pumper with SQ Flex line of pumps. So the SQ Flex is quite a flexible pump that accepts DC or AC going into the pump. And so you can connect a wind turbine directly, or a solar panel, or the grid. You can do any of those three. So, but you see a lot of SQ Flex pumps or a lot of pumps running in solar, but you don't see almost any wind manufacturer working with wind electric water pumping. So I think there's a niche that needs to be developed. What needs to be done at this point is quite a bit of testing. I'm starting to do some testing, but there have been some experiences. I built a test bench, and I started testing, or trying to start testing the water pumper. I have some glitches, so when I go back to India, I will continue doing the testing. I was hoping I would have a curve, like everything really beautiful, but I'll have to email it to you next month. But there are tests done in South Africa. Actually that's the bench test. Basically, we built this in order to take it to the site. I don't have a lab. I wish I had the lab that you guys have here. That would be very nice, but I don't. So what we did is we built a bench test that is portable. So we can carry the bench test to a farm, connect it to a pump, and get some data out of it. So it's the poor man's bench test. It worked. We tested it once. We had some vibration issues, so when I go back, I have to reinforce and test again. Anyway, the overall efficiency is about 10%. This is kind of like what you would get from the energy in the wind versus how much energy we can get actually out of the pump. Yeah, so this is basically from studies from in Texas, with USDA, the U.S. Department of Agriculture did some testing, and that's kind of a rough number that you can get. Yeah. I'll just go quickly. I'll show some curves. This is an example of a pumping curve for wind electric pumping system. This would be for a 1 kilowatt turbine, yeah, and 3.6 meters in diameter, 20 poles. These are mathematical curves, yeah. So these are not actual curves from a tested machine. We have this other one, which is for the 3 kilowatts, yeah. Each line would be for a different wind speed. Yeah, we have from 3 meters to 7 meters, each one of them. You will find similar curves on Grunfos in the XQ Flex manual. You will see similar ones. The difference would be in the Grunfos model, you will start seeing them starting at 4 meters per second. Yeah. These types of systems cannot work at 3 meters per second, you could say, because the wind turbine and the pump, and especially the pump, cannot work at low hertz. If it runs below 20 hertz, you will have cavitation problems, and your motor will overheat probably. So essentially, wind electric water pumping, you require slightly higher wind speeds than the same application for battery charging. So the guide or the rule of thumb I'm using is you need basically 5 meters per second or better to consider installing a wind electric water pumping system. Yeah. These are actually tests done in South Africa in the University of Stellenbosch. You can Google it. And it's a master's thesis. And essentially, these are actual. They built a Piggott turbine, a 20-pole turbine, and essentially they ran the test for 7 meters in height. So it was it wasn't a submersible pump, but a surface pump. And so, based on the calculations, there's a slight difference between the calculated and the measured. But you could basically say that if we had, and this was done with a 1 kilowatt stator running a 3 HP motor. But if you had a 3 kilowatt stator connected to the 3 HP motor, you could probably start a little bit lower in wind, and you would obviously go higher. They only went till 9 meters per second because otherwise they would have burnt the motor or something like that. So, but this is my reference point. So I went ahead and you saw the test bench has a stator and it has a generator. So we've actually built the stator. We've built the generator, and when I go back, I will do the testing on a 3 HP motor. And if anybody wants data on that, I'll be happy to share. Yeah, give me a month or two to do that. But what is the immediate aim? The immediate aim is we have a project in the south of Tamil Nadu, an area where there's thousands of these pumps that farmers have in basically banana plantations. And there's wind farms everywhere around there. So wind speeds are around 7 meters per second, annual average in this area. And the idea is to create a model to get started in actually going in there and maybe leasing systems or getting government involved to try to finance the systems. And we're looking for partners to be able to actually do something especially in these areas where obviously a wind electric systems would be probably a success. And that would be a really wonderful thing to get started. So we're always looking for volunteers and for funding, blah, blah, blah. So, like everybody else. That's an image of where we are. Pondicherry, where MinVayu is based, is in upper right. And we're basically in the southern tip of India. It's essentially in this area here. But I'm looking at just one area, which is a dry riverbed with thousands of water pumps. In India, there's a law that says if you have a wire and you have power, as a farmer, you get free electricity. But there's so many pumps in this area that the government doesn't even dare to put a wire because they would lose a lot of money. So anyway, it's an opportunity to be developed. And I think that's it. Thank you.